Rockfalls are a huge geohazard in Zion National Park. They are a natural part of the the geologic processes that form this canyon, but when humans and capital investments are in the way, it can cause a problem. We're standing here in front of an historic house. These houses have been occupied since the early 1930s, but unfortunately, we're sort of at the base of a cliff. In 2019, we had some geotechnical engineers come from the Federal Highways Administration who identified an 18-meter tall pillar above this housing unit. What we've been seeing at this pillar is that it propagates outward during higher temperatures in the heat of the day and warmer seasons, and it contracts closer to the rock surface during cooler times of the day and cooler seasons. Eventually, it's going to hit this angle of repose and topple down. We need to understand the geometry of the pillar, understand its center of mass, center of gravity, and what angle it's sitting at. And so we can figure out potentially, when this pillar might finally fail.
So our job was to create a 3D model of this pillar, which we did by scanning it on as many faces as we could.
This is a terrestrial laser scanner, also called a lidar, which is like radar but with light. So right now it's shooting a laser beam very quickly over and over again at this wall face that we're measuring, and then recording how long it takes that laser to come back, and from that it can make a model of the surface.
The first day that we were there, we scanned the bottom part and the sides. And then the second day, we went to the top of the pillar. There's a vertical section right above it, and so we needed to rappel down into that area in order to set up the scanner on top of the pillar to look down into it. To do that, we had to meet with the search and rescue team, and then they lowered both me and the gear down to this little ledge that was right across from the top of the pillar.
In this region, rockfall events are a major part of how bedrock turns into sediment. Erosion and sediment transport and tectonics are all interacting in this area. So basically it's a collaborative relationship between us and the national park. Kind of grew out of an initial sort of residency that I did here last summer. And so yeah, now we've got a couple of students who are interested in working on the data. Obviously, I mean, this is a great plug for UNAVCO. The ease of accessing the resources there was really a big part of the reason why we thought this would be a good first step to take on this rockfall stuff.
My family and I moved out here about 10 years ago, and we've been to Zion so many times. And when I heard Alex talking about it in class, I thought it was just a great opportunity, super excited about it.
Some background I've done on the area before coming out here was finding the area of the boulders that have already fallen to try to correlate that with slope.
What we find from the pillar in terms of looking at the geometry, how long it's going to take to fail, thinking about what are the processes that are driving its movement, is it sort of a diurnal heat cycle? Is it something to do with water saturation in the substrate there? Those are going to be broadly applicable to understanding both management questions in the area and also sort of the science of what's driving erosion.
So in late August 2019, a giant plate of Navajo sandstone came down from the top of Cable Mountain, crashed at the top of this amphitheater complex where we have a series of switchbacks going up called the East Rim Trail. This rockfall hit the top of the switchbacks and pulverized into sand and dust and cobble-sized blocks and a few boulder-sized blocks. And so the park is in the process of collecting as much data as possible to develop a risk assessment. And one of the biggest unknowns for this particular risk assessment is the frequency of rockfall events.
We set this up yesterday afternoon, and we are leaving it in the exact same spot for a 24-hour period, taking a scan every hour to try to measure any motion that's happening on the rock face.
Historically, rockfall has a lot of it's been attributed to things like the freeze-thaw cycle. There's been a growing recognition that many of these really large rockfall events occur when it's hot out, at the peak of the heat of the day. And so we're looking to see if we can observe this signal that's been observed elsewhere of basically a thermal expansion and contraction along joints. Basically, you get these exfoliation sheets that will bow outward and also that the cracks that are controlling those sheets expand. And of course, the expansion of those cracks is of interest because it could potentially lead to these massive catastrophic failures. Depending on whether that kind of behavior is happening here and depending on the magnitude, you know, we're hoping with the TLS data that we'll be able to really, with that really high resolution imaging of the wall, that we'll be able to see some of that sort of diurnal displacement cycle. Being able to look at this wall specifically also potentially could address all these questions about just how does the canyon get carved and shaped as a whole.